Okay, can you hear the spacey type music going on in the background? That's part of a website that I'm on right now. I'm going to show you in a minute here. I can turn the music off. Maybe I will if I get sick of it. But anyway, this video is about atoms and how big, or maybe how small they are, would have been better to say. What are they made of, and what we study in this class in general. I want this to be no more than 6 minutes. We'll see if I can do it. Okay, the website that I was telling you about, where is it? It is right here. Okay, if you go to the internet and type in scale of the universe, you'll get this somewhere. I've seen this on different web pages. I'm at htwins.net/scale2, but even if this website goes away someday, I'm pretty sure this animation is going to live on because it's pretty darn cool. Okay, we'll leave the sound on for now. So what you're seeing is 1 times 10 to the 0. So basically we're talking about things that are on the order of a meter across. This circle is a meter across. So someone like me, I'm not quite 2 meters tall, so that circle, I'm almost 2 of those circles tall. Now this website, you can scale out and see bigger stuff. And every time you go up one number, like down here in the bottom it says 10 to the 1. So now we're talking about things that are 10 meters across. So I'm not interested in the big stuff here. I'm talking about small stuff. I want to talk about atoms. So I'm going to start zooming in, and we're going to see what we can see, and I'll stop a few times on the way. So 10 to the negative 1, that would be 1/10 of a meter. So that's what, 10 centimeters or so. Okay, exactly 10 centimeters. And these are some things that you can measure with that kind of a scale. Earthworm here, chicken egg, that type of stuff. So then we go down to 10 to the negative 2. That would be a centimeter or so, and we're in the neighborhood of ants and stuff. Grains of rice. Let's keep going. Remember, we're looking for atoms. All right, so are we getting close? Well, bacteria, they're small. You can't really see them with the naked eye, can you? Dust mites, I don't know, maybe some people can. I know I can't. An amoeba. So 10 to the negative 3, what's that? That is a millimeter. 1,000 of these would go onto a meter stick. In fact, when you look at my meter sticks, those tiniest little sliver marks on them, those are millimeters, and there's 1,000 of them on that meter stick. Okay, so let's go 10 times smaller than that when we find atoms there. 10 to the negative 4. Nope, but we're down to skin cells, infrared, heat vision type stuff, blood cells, 10 to the negative 5, chromosomes getting smaller. Where are atoms? Well, let's see, E. coli bacteria, you've heard of them. Viruses, around 10 to the negative 6. What is 10 to the negative 6? Well, that's a millionth of a meter. If you take this decimal 6 places over, you wind up right there. So now we're talking about micrometers. That's that weird little M symbol there. So we're 1,000,000 times smaller than a meter now. So let's go 10 times smaller still. When will we find atoms? Let's see here. Keep going. Okay, DNA, that's made of atoms. So is pretty much everything, but let's see here. Where are atoms? Okay, I think I see some atoms. There we go. Okay, cesium atom, water molecules. So we're at 10 to the negative 9th now. So 10 to the negative 9th. What does that mean? Well, that's moving the decimal 9 places, or you could say a billionth. So a billionth of a meter across, and you wind up at atoms and some small molecules. So there we go. Atoms can be about the size of a billionth of a meter. But what about the middle of the atom, the nucleus? Let's keep going. Wait a second. Finally got sick of the music. Okay, let's keep going here. So if we keep going past 10 to the negative 9th, when are we going to find the nucleus, the thing in the middle of the atom? So 10 times smaller is negative 10th, negative 11th, 100 times smaller, negative 12th, 1,000 times smaller. So we're something called a picometer. Negative 13th, that's going to be 10,000 times smaller, and if I start to lose count, forgive me. But here we are at 10 to the negative, about, let's say, 14th, okay? So if 10 to the negative 14th is how big a nucleus is, like here's a helium nucleus and a chlorine nucleus and a big old uranium nucleus, and here's an electron. So 10 to the negative 14th, and where did we first see the atoms? At around 10 to the negative 9, so 10, 11, 12, 13, that's 5 places. So that's, what's that, 100,000 times smaller. So the nucleus is eensy weensy, okay? So let's go back here. What's going on with this this video? Well, what are atoms made of? They are made of smaller particles. We call them subatomic particles, and you can slice even these particles smaller, but these are the big three that we need to talk about in this class. And hopefully they are things that you've heard of before. So we've got protons, which have an electric charge of +1. We've got electrons, which have an electric charge of -1. And we've got neutrons, and hence the name, it has no electric charge. So what kind of masses are we talking about here? How heavy, what's the mass of these little atomic particles? Well, you guessed it, really small. We're talking about 10 to the -24th grams. So you could almost say, well, geez, they weigh practically nothing. Well, that's kind of true, because we can only really appreciate them when they gang together in like big objects like people or rocks or whatever. Now, the mass of an electron, look at this, 10 to the -28th. What does that mean? That means that it's 4 magnitudes of order smaller, or less massive than the other particles. So that means, what, 10,000 times less. So usually in chemistry type stuff, we kind of ignore the mass of the electron because it's 10,000 times lighter, so who cares? Somebody came up with an idea, and I think it's a good one. Rather than dealing with these kind of numbers, they decided to compare them all to, I think it's either a proton or neutron in a carbon nucleus, but they said we're going to compare them all to each other. So the proton weighs basically 1 atomic mass unit, and so does the neutron, and then the electron we kind of ignore because it just weighs practically nothing. So that's what an atom is made of. So what we study in this class, I guess in order, I would say the protons. Ooh, wrong color to use there. Protons, because that's what gives an atom its identity. That's called the atomic number. And the electrons. The electrons are also important because they determine what an atom is going to do with other atoms. And then the neutrons make atoms heavier or lighter. That's called isotopes, and we'll talk about that later. But I've gone over 7 minutes, so I'm going to stop. That's the basics of how big atoms are and what's inside them, pretty much.